Manipulating rational expressions. I'm going to do the last three problems of the Prepare for Class 2.5 question 4. These all use the same algebraic fractions, so I only really have to factor them once to show you how each is done. None of these can be solved because I don't have any equations. I can't ever figure out what x is. I can, however, combine these two fractions in various ways. This first way, they're asking me to multiply. So when combining algebraic fractions or rational expressions, it is critical to factor and simplify before you multiply. So x plus 3 is already prime. X minus 3 is already prime. I can't factor either of those. I did put parentheses around them. That helps me remember that they are factors, and they have to stay together. 4x plus 12, I can factor out a 4 to give me x plus 3. And so I'm going to cross out my 4x plus 12 just so I know that I have it factored just above it. X squared minus 9, these are perfect squares, the difference of squares, and it factors as x plus 3 times x minus 3. So now I have 4x plus 3 over x plus 3, x minus 3, and I can divide out these two like factors. I can divide out x plus 3 over x plus 3. This simplifies it much more, so now I have x plus 3 over x minus 3 times 4 over x minus 3. The rule for multiplying algebraic fractions is to multiply numerator, numerator, multiply denominator, denominator. So this is going to give me 4 times x plus 3 over x minus 3 squared. I would leave it like this in simplified form rather than expanding things out, because odds are whatever I do with it next, it's going to be easier if I have it already in simplified form or factored. Next, we're asked to divide. I have the same fractions, I'm just rewriting them here. Divided by 4x plus 12 over x squared minus 9. The rule for dividing fractions is to take the reciprocal of the divisor, the second fraction, and make it into a multiplication problem. So this becomes this multiplication problem. Flip it before you factor, because then you don't forget that you're still dividing when you're factoring over here. And you can start canceling here. X squared minus 9 factors into x plus 3 times x minus 3. 4x plus 12 factors as 4x plus 3. I can divide out x plus 3 with x plus 3. It's a little messy, so I'm going to rewrite it. X plus 3, I'm going to put in parentheses over x minus 3, also in parentheses, times 1 I don't have to write down. I'm going to write down x minus 3 over 4. Because I'm multiplying, and the rule says I multiply numerator and numerator, denominator and denominator, so this is kind of like I have one whole fraction, and I can divide out anything in the numerator, either numerator, with anything in either denominator. So I'm going to divide out this x minus 3 with this x minus 3. I get x plus 3 times 1, which is just x plus 3, over 1 times 4, which is 4. And this is my simplified solution. Please don't make the mistake of multiplying first and getting some complex polynomial and trying to simplify that. Even I won't simplify those. Simplify before you multiply. Simplify before you multiply. The last one we have is a subtraction. Addition and subtraction are different than multiplying and dividing. In order to add and subtract fractions, you have to have common denominators. So I'm going to have to build to a common denominator. I can't just simplify. I can't just cancel out terms. You can never cancel out terms. You can only cancel out or divide out factors. Oops, sorry, I should have written down x squared minus 9 here. I already have it factored. The first thing I do, yes, is factor, especially my denominators. So I have my denominators factored. I'm going to put this in parentheses. So I know it's a factor. It has to stay together. Then I'm going to find my least common denominator. I like to write it down on my paper, least common denominator. That's going to be x minus 3. And it's got to have an x plus 3. This already has an x minus 3. It only has 1. So my least common denominator is going to be x minus 3 times x plus 3. In order to subtract these, I need to build this fraction up so it has the least common denominator, which means I'm going to have to multiply by x plus 3 over x plus 3. When I put down my x plus 3 here for beside my numerator, I'm going to make sure the numerator of the original is in parentheses. I don't want to forget and only distribute part of that multiplication. I've got to distribute it to both the x and the positive 3. I'm now going to multiply this. This is going to give me x squared plus 3x plus 3x plus 9, which is going to be x squared plus 6x plus 9. I am subtracting. I have common denominators here, so I can subtract 4x plus 12. Please notice I put that in parentheses because I want to make sure to distribute that negative. Otherwise, I will get it incorrect. It's over the common denominator. It's important that it's the least common denominator, again, because otherwise you're going to end up with polynomials that are very difficult to simplify. I'm going to distribute my negative. So this will become a positive, this will be negative, this will be negative. Now I can get rid of my parentheses. I'm going to have x squared plus 6x plus 9 minus 4x minus 12 over x plus 3, x minus 3. Notice I leave my denominator factored. This is going to be x squared plus 2x minus 3 over x plus 3, x minus 3. Note, I am not done. I am not done. I need to look and see, does this factor? And yes, indeed, this does factor. It's going to factor as x plus 3 times x minus 1. I factored it by guess and check. Check. That first term is x squared. The last term is negative 3. This middle term is 3x minus x, which is positive 2x. So it's factored correctly. So now I can divide out my x plus 3 over x plus 3. And I'm left with my solution, x minus 1 over x minus 3, which does not simplify further.